Today we're going to be looking at sound waves in GeoGebra. I've copied the equation for a sound wave here. It's actually modeled by sine waves. We've got some variables in here that we can adjust to see what happens to the sine waves. A in this equation represents the amplitude of the sine wave, and what that translates into for the sound wave is what the volume of your tone is. This is omega, and it represents angular frequency mathematically. In the natural world, it represents the pitch of that particular tone. This is phi, which is phase in the mathematical world, but in the natural world, this is the shift in time for each sound wave. Now, whenever you've got two or more sound waves that interact with each other, we call that superposition, and there's one of two results that could happen. Either it could amplify the sound of each other and the pitch and all of that, and the other thing that it could happen is it could diminish each other. For example, one sound wave combined with another sound wave could actually combine to create no sound at all. And what we're going to do in GeoGebra is to simulate this superposition using the slider tools. So first we're going to create 3 sliders, and you can put them anywhere on the page. I'm going to put them here on the right hand side. Here we go. And I'm going to label that A sub 1, and I want to increment this by 0.5, and I'm going to create another one. This one is going to be omega, and you can find the Greek symbols down here at the bottom on the keyboard. Just click the Greek ones and then select omega. And this is going to be sub 1. We're going to increment this by 0.5. And we're going to create a third slider, phi. These look very similar here, but this one here is the one for phi. And make sure it's sub 1. The increment is 0.5. And you could do any increment. The reason why I'm doing 0.5 is because it's just easier for me to look and see what happens if I look at it by increments instead of just moving the slider up and down. And I'm going to change the color of these sliders, so I'm going to right click on each one. Oh, cancel. Make sure you've got your move tool selected. I'm going to right click on each one, and I want to change the color so that we can color code our graph as well. I'm going to make all these blue. Just in the settings, select color and then select the color that you'd like. Okay, so the equation that I'm going to write that's associated with these 3 sliders is also going to be blue. We're going to put that in over here. And it's going to be g of x equals a, it should be sub 1, but I like to put in my subscripts afterwards so that the program is not confused with superscripts, subscripts, and regular scripts. So a times sine of omega times x plus phi. And now I'm going to go back in and add my sub 1s and do that in the same way with the underscore. Okay, so now it's created my equation. I've got all 1s here, and if you'll notice, when I move this, it changes the equation as well. We're going to leave that at 1. And we need to change the color of this so that it's color coded. So right click on it and go to settings, and we want the color to also be blue. Now we've got these matching that particular equation. Next, what we're going to do is we're going to put in a second sound wave here using my sliders first. So I'm going to create a slider alpha sub 2, increment that by 0.5, and omega sub 2, increment that by 0.5, and then phi sub 2, increment that by 0.5. Okay, and I'm just placing them randomly here, but I kind of like things symmetrical, so I'm going to try to make it as symmetrical as I can. We're going to change the color on this as well. I don't like gray. Let's go with purple. No, that's a little bit too close to blue. Let's go with this green here. Okay, and so I'm going to select the same color for all the other ones. Notice it saves the colors for you that you've recently used. So instead of clicking on the new color, you could just click on the most recently used as well. For my input, I'm going to put in h of x equals, and it's going to be the same process as up here. So let me see if I can copy and paste this. Duplicate. Here we go. So here we're going to type in sub 2, and this one is going to change to a 2, this one's going to change to a, not a 3, but a sub 2, and then here at the beginning we're going to type in h of x. Okay, let me make sure that I've got that correct. H of x equals a sub 2 sine omega sub 2 x plus v sub 2. And I want to change the color of it. Since on here I won't be able to distinguish which one is which, I'm going to right click on here, and I'm going to go to settings and change the color here this way. Select the green. And now I want to make a sum. Now if you type in sum, it's going to give you the summation. So we're just going to call it function s, since it's the sum. And that's going to be g of x plus, got too many parentheses there, hold on a second, g of x plus h of x. So that's my sum there, and it's orange. That's different than the other ones, so that'll work. So now I've got 3 functions displayed here, both sound waves, and then the sum of those 2 sound waves together. So if I change my amplitude to a larger number, notice that it changes the sum as well. If I change the angular frequency, notice that it does all kinds of weird stuff. It's basically increasing the number of times that happens in your how many times that wave happens in your time period. Here we've got the phase shift, and so all this is going to do is it's going to move it to the left or to the right along your x-axis. And we'll do the next part of this video where we answer some real questions so that we've got enough time to be able to upload it to YouTube for free.